we need to have another aspect when we come to comparing our estimates. When we compare our estimates, we need to have a hypothesis test. We need to say, what is the null hypothesis for our estimate, for our difference? And the null hypothesis is usually that there is no difference between the estimates. Oh, sorry, there's a typo there. And we need to say, well, how do we know whether 8% and 10% are different? And is 12% and 50% different? How do we compare those and show whether they are statistically different, statistically significant? And for doing this, we need again to have the standard error of the difference. And again, this is the standard error that we had for our estimates and for our incidence estimates. We can obtain these standard errors from our software packages. And these standard errors will tell us about the variability of that estimate we get. The estimate we get is from our sample, but of course, if we did the same sample again, or a different sample from the population, we would get a different estimate from that. And standard errors of our differences depend upon the outcome that we're looking at. If we have a continuous outcome, if we're looking at the score, let's say the mental health score might be getting from a particular tool, then we might say, well, we're going to compare the mean in one group with the mean in a group to see whether they have different mental health scores. And the difference is the difference between the two. And the test statistic is going to be the difference divided by the standard error of the difference. And the standard error of the difference depends upon the normal distribution here is going to be S squared, the variance divided by N for the first group, and S squared divided by N2 for the second group. In other words, the variance in one group divided by N, and the variance in the second group divided by the number in that group. And that's going to give us the standard error of the difference, so that we can use this in the comparison and to see whether or not that difference that we observed is significant or whether it's small. For proportions, again, the difference is going to be the proportion in one group minus the proportion in the second group, but the standard error is going to be different because it's based upon a different distribution. And in this case, it's the binomial distribution. And so we have P1 multiplied by 1 minus P1 over N1 plus P2 times 1 minus P2 divided by N2 in the second group. We add those two variances together, and then we take the square root of that to get the standard deviation of our difference, a standard error of our difference, sorry. And we can use the standard errors to compare the differences that we observe and see whether or not they are significant.